Now, I can't recall if I've done these announcements for this class. This class is an early class, and sometimes I forget them first thing in the morning. Did I do either of these announcements? I did. Okay. College Transfer Fair Day coming up Wednesday, February 12th at the Birmingham campus, 9:30 to 11:30 on this campus in the best, probably in the faculty staff dining room. And there's a whole bunch of schools will be here, so try to plan to be there. And can I get your name, please? Childress. Okay. Is that Minuet? Yeah. All right, good. Anyone else come in since the call roll? Okay, the second of these is the Summer Research Program. Y'all remember that one? Okay. Great deal, especially if you're pre-engineering, especially going toward mechanical, electrical, or materials engineering. The others could probably benefit as well. 10-week summer internship. They pay you to be there. They pay to get you there. They house you for free. And I think that includes feeding you for free. So it's quite a great deal. I've got the information here if anyone's interested in looking at it. Yeah, come pick it up right after class. And if you will, leave it with me. But, review it, get the pertinent information on it. It's a fantastic program. All right. Now, I believe this is where we left off last time, but before we do, any questions for anything we've covered so far? All right. Now, I believe the last thing we actually did was plugging in the values, that's evaluating functions, and then noting that these three functions, even though they look totally different in many respects, they're the same function. Name, please. Marina. Is that Trinity? Mm-hmm. Okay. All right, good deal. It doesn't matter what you name it, and it doesn't matter what the independent variable is. As long as the operations are the same, they're the same functions. And you're squaring the input variable, subtracting 4 times it, and adding 7. Squaring the input variable, subtracting 4 times it, and adding 7. Yeah. It winds up that your independent variable, which sounds very independent, is just a dummy. Doesn't matter what's there, okay? As long as the operations are the same. So it really doesn't matter what you name it, as long as the operations are the same. So basically, your independent variable plays the part of a placeholder, okay? Here's another way you could do it. I said stickman. This says whatever. Gray box, okay? Alpha gray box is gray box squared minus 4 times gray box plus 7. Same function as the other 3 on the previous page, okay? Doesn't matter what you name it, as long as the operations are the same, it's the same function, okay? Generally, we'll try to name it the same thing so it's not so confusing. And if you get your name, please. S. Tenson. Okay. Jemiah? Okay, got it. All right, good deal. Okay, anyone else? No. This next sentence here belongs on a different slide. Okay, we're going to come back to this in a moment. Let's do first example 3. Okay, let's see if I can find a little more white space to work on. Yeah, a little bit more here. So let's do example 3. Any questions so far? Okay, here's example 3. Now, for those who didn't come in earlier, I forgot my reading glasses today, so I'm having to get far enough from the page so everything's in focus, but if I get too far from the page, it's too small to read. So I may need your help in reading some of this. Here it says, let g of x, let me get my pen set up so I can see it. Let g of x, okay, equal minus x squared plus 4x plus 1. Then it says find each function value. The A one here is find g of 2. What would we do? Plug it in, okay, just like Glade. Minus what? Yeah, 2 squared plus 4 times 2 plus 1. Perfect. Now we run into a little bit of a dilemma here, and I think someone is already doing it correctly, but I chose to plug it in individually so everybody can see this. This gives us a little bit of a pause here. What does minus 2 squared mean? It's what? Not quite. If the minus 2 were in parentheses, that's exactly what it would mean. But do y'all remember the little phrase, please excuse my dear Aunt Sally? I don't know what she did, but please excuse her, okay? Now, what does that mean? Anything in parentheses you do first. Therefore, I said if that was negative 2 in parentheses, you do that first, okay? Then, excuse is exponent. You do that next. Then you do, my dear is multiplication or division, and then lastly, addition or subtraction, Aunt Sally, or Sue, or whoever it is, okay? Now, the negation is a lot like a subtraction. That's just about the last thing you do, okay? So this says do the exponent before you negate. So when you square 2, you get 4, and then you negate that. So that's a minus 4, and what does this give you? Plus 8 plus 1. Now once you get to addition and subtraction, it really doesn't matter. Same thing with multiplication and division. So it matters a little bit sometimes, but not really too much. Here, what I like to do is add the positives and subtract the negatives. But you can do it any way you want to. This would be, if you did it in the order you see, minus 4 plus 8 is plus 4, plus 1 is 5. Or if you added the pluses together, that would give you 9 minus 4 is 5. Just a little easier in my book, but it's okay. All right. Any questions on that? The book got it right. Good for them. Okay? Now, let's do the B part. What is G of T? Ooh, what do we do there? We're going back to the original. Plug a T in. Everywhere you see an X here, put a T there because you see the T replaces the X. So this would be negative T squared plus 4T plus 1. Done. That's all you do. Yes?
Are you doing the practice problems you gave us last week?
Okay. I'm doing the example 3 on page 38 in the book.
Okay.
Right. Okay. When you said the practice problem, you meant the examples at the end of the section?
Yes, sir.
Okay. Anytime you have questions on those, great time to ask. Anytime. But especially at the very first one, I say, have you got any questions so far? Great time to ask. But anytime like now, great time to ask. Any questions on those?
I know Kim said she had a problem that she understands.
Okay. He's speaking for you. Okay. Which one? We're doing it right now? Okay. If anything else comes up, let me know. Anytime. Okay? I was in the Navy, and Navy is not known necessarily for its great school system. They have Navy classes for various rates and things. But there is one thing I ran into every Navy class that I ever went to. I guess the instructors were told to say this. He said, there's no such thing as a dumb question, except one. That's one you don't ask. Once you have a question, if you ask it, it's not done. If you don't ask it, that's done. Okay? So please, if you have any questions at all about what I'm doing, about homework, anything else, ask. About those checkpoints, ask. Yes? Why is what? Okay, good question. All right, here was the original function, right? Okay, we put the minus sign here. Okay, minus sign here. We plug in the 2 there and the square here. And then the same thing there. Now, what we just said was, when you have a minus, which is the subtraction or negation, okay, and an exponent. Please excuse my dear Aunt Sally, exponents come before subtraction. So you square that first, make that a 4, then you subtract. Make sense? Yeah. It's called the order of operations. And the shorthand for it is, please excuse my dear Aunt Sally. I think some people like to do the PUMDUS or something like that. If you learned it that way, you can use that, and I never can remember what that acronym stands for. Okay? Now, B was pretty easy. You just, instead of X, you put a T. But let's see what C does. Okay? If I could read it. G of X plus 2. Whoa. Huh. What do we do there? Get your name, please. Fitzpatrick, got it. John, right? Good deal. Okay. You had a few minutes to think of it. What do you come up with? What do I write to? Yeah, negative first. Now what? Open parentheses. Say again. X plus 2, close parentheses, squared. Next. Plus 4, open parentheses, X plus 2, plus 1. Perfect. Everywhere you see an X up here, replace it with an X plus 2. Now, because you're doing operations on it, put those in parentheses. Put that X plus 2 in parentheses. There'll be a minus X plus 2 squared plus 4 times X plus 2 in parentheses plus 1. Make sense? Now what? Say again? A little louder. Okay, we square the X plus 2. Leave that minus sign alone, okay? We aren't coming to that until later. So what is X plus 2 squared? Okay, I hear a X squared. And put it in parentheses now. X squared. Say again? Did I hear 4X or 8X? Okay, yeah, plus 4X, perfect. Plus 4, is that right? Okay, my hearing's terrible. My vision's bad, my hearing's bad, I'm falling apart. Okay. Next. Plus 4X. Plus 8, no X, plus 8. And plus 1. One more little thing to do. Negate the stuff in parentheses, and that's a negative X squared. And, what'd you say? No, minus times 4X is minus 4X. Minus 4 plus 4X plus 8. Or you could say plus 9 if you wanted to. You want to go and do a plus 9? I'm really lazy. Okay? Plus 9. I like it. Okay?
Why do you have an 8 on there 40 when we did 2 to the 6?
Okay, which one? This one? This one or this one?
The first one.
The first one.
Yeah.
Good question. Okay. Because she told me to. Okay, no, okay. Here's why. There's 2 ways you can square a binomial. I understood that whoever it was calling it out to me knew the shortcut. Okay? If you don't know the shortcut, here's what I do. I would come off to the side. This is called scratch work. What does x plus 2 squared mean? What does it mean to square something?
X plus 2 plus x plus 2.
Not plus, times. You multiply it by itself. That would be x plus 2 times x plus 2. And then how can you do that? FOIL it, exactly, okay? What does the F stand for? First, so first is x squared, and then O is outer, and that gives you a plus 2x, and then the I is an inner, which is plus 2x, and then last is a plus 4, no x, plus 4, okay? You love those x's, don't you? Okay. Now we combine like terms, and what do you get? X squared plus 4x, that's where it came from, plus 4. Okay. Now, here's the shortcut. If you're squaring that binomial, oh, and by the way, you got it right, so you get a smiley face. Okay, good. Wonderful. Okay, now, if you're squaring a binomial, what's the shortcut? Square the first. X is the first. Square it. That's exactly what we did here. And then we did twice the cross product. You multiply these together, you get 2x. Double that, you get 4x. So here's what we did. There was a 2x, there's a 2x. So we doubled it. So square the first, twice the product, square the last. And that's what we did there, square the last. So that's the shortcut. If you forget the shortcut, FOIL it. Okay? Make sense? Okay? Now, keep that in parentheses, and then you negate everything. All right, now what's the last step here? Combine like terms. Any like terms with x squared? Nope, that's the only one, so just write down minus x squared. How about the x terms? Yeah, you got a minus 4x and a plus 4x. They add to 0, so they disappear. And then you have a minus 4 plus 9 is plus 5. There you have it. And then guess what? The book got it right too, if I could read. Okay. Does that make sense? Any questions on those? Understood? Sorry, I'll try to write a little higher. We'll talk a little higher. No, I won't do that. Okay. All right. After every example, there's a checkpoint. Okay? As soon as you get out of class and have some free time, try to do these checkpoints, because that will do it while it's fresh on your mind, as fresh as possible. And if you run into difficulty in the checkpoint, you can go to LawrenceandPrecalculus.com and find them worked out. Audio, video solution to them, so you can get help doing it. Okay? Would this desk up here make it easier? You're welcome to come. Okay, got it. All right. Any questions there? All right. What I'm going to do is go back to that slide we were on. I'll let you see people still writing. Don't let me move off too fast. If you have questions, please ask. Okay. All right, to move on? Are you still writing? Still writing? I'm sorry? Yeah.
I tried to do it, but I could never find it. It was like saying it was like on CalChat and CalView.
On what?
CalChat and CalView.
Oh, it's CalChat. C-A-L-C.
I pulled it up and it was like, it didn't look like a problem.
Right.
That's why I wasn't able to understand.
And those were the odd number problems is what I assigned.
Mm-hmm.
Right.
It was weird. And then, I don't know. Like, it don't show you how to work the problem out.
It just shows the work. Okay. The Calc View takes you through it a little more slowly. So really you need to see the homework and you try it, and then if you can't get the answers in the back, then go to CalcChat. Okay. Okay. Some people came by and took pictures of the homework page. You can always do that. Yeah, let's do that. I can remember not that many years ago when the books hadn't come in yet or something like that, or people couldn't get their books yet, I'd have to go down and make copies of it. Now everybody just comes and takes pictures of it, which is a lot easier on me, but yeah. All right, so yeah, by all means, if you don't have a book yet, please do that. Are you doing the Cengage Unlimited? Oh, you're not doing that? Okay. So if you can get anyone with a book or that ebook, the problems are all there. Come take pictures of mine. Any other? Everybody get caught up? Can I move on? Okay. All right. If we go back to this one, like I said, these two lines should have been on the new slide. A function defined by two or more equations over a specified domain is called a piecewise defined function. That's near the bottom of page 38. Okay? Here's an example of this. Okay? Yes. Sure. No, I don't do anything real quick, but where? Right here?
Right there.
Okay. I could do that quick. Okay. Quickly. I'm old and slow. We had already done the first two lines. The second two lines is where I said the slide should be split up. Because example 3 was in between the first two lines and the second two lines. Okay? Everybody, some people still writing. All right. Everybody got it? Okay. Here's an example of a piecewise defined function. F of x, that function, is this function anytime x is less than 0. That means any negative x. But it's this function anytime x is greater than or equal to 0. So anytime x is 0 or positive. So it's this function when it's negative, this function when it's 0 or positive. So what they want us to do is evaluate this function f of x at each of those three values. Okay? Now, I have a dumb way of doing it. You don't have to do it this way. Let's do f of, instead of x, we put a -1. Now, before you start evaluating anything, what I say is find out where you are, Waldo. Where are you here? -1 is where? It's less than 0. So we go to this form. You only go to one form. Remember, a function only has one value for any input. So you go, -1 is less than 0, so we go up here. And we'll plug in there. So what would that be? Say again? -1. Say again? Squared plus 1. And what's -1 squared? 1 plus 1, 2. Didn't know you'd be doing such high-level math today, did you? 1 plus 1 is 2. Okay, we got it. Okay. Now, goodness gracious, I can't read. Yeah, okay. Then the next one, f of, this time we'll put in Put in 0. Good. How'd y'all figure that out? Okay. And where are we, Waldo? Before you plug anything in, figure out where you are. You're in the first one? Is 0 less than 0? No. Yeah, 0 is equal to 0. It's not greater than 0, but it is equal to 0. So we go to the second one. What do you get then? 0 minus 1, which is -1. Right? See it? Okay. How about the next one? F of 1. Where are you, Waldo? You're the second one because 1 is greater than or equal to 0. Not equal to, but it's greater than. So we go down there, and what do you get? 1 minus 1 equal 0. Perfect. Perfect. You see how that worked? First, figure out where you are, and you see the domain of this function is all real zeros, because this covers every 0 that's negative, and this covers 0 in every x that's negative, and this covers every x that's 0 and positive. So your domain is all real 0. But the first part of your domain is just this function. Second part is that function. It's called a piecewise defined function. Now, did someone just make this up just to make something else difficult to do? Why not? You run into these ever? Have you ever mailed a letter? Okay? If that letter was 0 to 1 ounce, you're going to pay a certain postage. But if it's between 1 and 2 ounces, you're going to pay another postage, right? 2 to 3 ounces, another one, right? That's a piecewise defined function. That's why they put it on a scale, see what it weighs, and then they tell you the postage. Piecewise defined function. Anything less than an ounce is always the same. For 0 and 1, it's always the same. Piecewise defined function. Some of your cell phone plans may be that way. If you use, I don't know what, 0 to 100 hours, it'll be one rate, but if you go up to 100 to 200 hours, it may be greater. I just made up the numbers. Yeah. There are lots of things out there that follow those kinds of rates. Okay? Maybe some of you work jobs that during the week you get a certain rate, but if you go overtime, that may be 1.5 or double. That's a different rate. It's a piecewise defined function. Okay? Or if you work a weekend, it may be greater. Some, they don't care. They can pay you the same. But anyway, those are piecewise defined functions. All right? Any questions on that? Let me go back, erase what I did, and we'll see how they do it. Because -1, the first one there, is less than 0, we use the top function here, and we obtain that. And what does that give us? Say again? 2. -1 squared is 1, plus 1 is 2. Okay? All right, the second one, because 0 is in which group? First or second? Second. Then we use f of x equal x minus 1, because that's where you are. Okay? Then plug in a 0 there. 0 minus 1 is -1. Perfect. And then the third one, because x equal 1 is greater than 0, we use f of x equal x minus 1, and 1 minus 1 is 0. Perfect. Okay, just like we did. Any questions? All right. Now again, there is a checkpoint. Please do the checkpoints as soon as you can. I wish we had time in class for them, but we don't. Now, if you'll notice, the domain of a function skips over to a whole page. They've skipped examples 5 and example 6. These are 2 of the most important examples in the section, and they skipped them. So let's go back and find some place to write. So let's do example 5 and 6 here. Finding the values for which f of x is equal to 0. Okay? The example says find all real values of x for which f of x is equal to 0. Okay? The A problem here says f of x is equal to -2x plus 10. Right? All right. Now, what are they asking us to do? Find the value for x that makes f of x equal 0. What's f of x? That, right? And what did they say do to it? Set it equal to 0. So all you do is set this equal to 0. Just do what they tell you to, all right? Didn't Mom always say that? Just do what I say. Okay, no, okay. Now, How do you solve that equation? Just a simple, say again? Subtract 10 from both sides, is that what I heard? Say yes. All right, good, okay. Subtract 10 from both sides. And what does that give you? Negative 2x, this adds to 0, is equal to negative 10. Now what do I do? Divide by what? Negative 2. Both sides by negative 2. Here, everything goes out except the x. Over here, what do we get? 5. Okay? Now, I'm sort of a cynic. Okay? I want to make sure I got that answer right. So what I'm going to do is go back and plug in 5 for x. Negative 2 times 5 is negative 10 plus 10. Yes, is equal to 0. I feel good about it. Okay? The b part here is f of x is equal to x squared minus 5x plus 6. And what does it say to do? Set it equal to 0. Okay? We're looking for the x's that make that sentence true. Make that equation true. Now, what would you do with this one? Say again? Factor. All right. Excellent. Okay? Now, how do we go about factoring that? It may not be factorable, but we sure hope it is. How do you go about factoring that? Okay. Here's my little technique. Yeah, I never have seen this in a book, but I may have, but they don't usually talk about it. I unfoil it. Remember y'all told me to foil before? Let's unfoil. So let's start with the first. What's the only two factors of x squared? X times x, okay? First, right? Now, let's go to the last, but I don't want the whole last term. I just want the sign of the last term. We're going to, oh, I'm not spelling foil right, am I? Okay, unfolding. Never mind, I'm unfolding. Okay, let's go to the last term. What's the sign of that last term? Positive. That means these two signs here must be what? Must be what? They have to be the same. The only way you get a product being plus is if the other two factors are the same sign. Either two pluses or two minuses. Since the middle term is a minus, then this has to be a minus, that has to be a minus. So I'm going to take out my blanks here, okay? Now the question is, what two numbers, both negative numbers, multiply to be 6, add to be minus 5? Say again? 1 and 6. Okay, let's try 1 and 6. Okay, so sure enough, they multiply to be 6, but when you add them together, what do you get? Oh, 3 and 2. See, that adds to be minus 7. Doesn't give you this. So 1 and 6 doesn't work, but 3 and 2 do work. 3 and 2. They multiply to be 6, add to be negative 5. Got it? Okay? Now, what do we do then? Set each of them equal to 0. Because the only way you can have the product of two entities being 0, one or the other of them got to be 0. Can you give me any two other numbers that multiply to be 0? No. There are none. One or the other has to be 0. So either x minus 3 is equal to 0, or x minus 2 is equal to 0. Only way those two things can multiply to be 0. One of them has to be 0. What does that first one give us? X equal 3, or x equal 2. Okay? Now again, I'm a cynic. Now I don't want to believe this until I prove it to myself. What's 3 squared? 9, okay. And minus 5 times 3 is? Okay, negative 15. 9 minus 15, what would that give us? Negative 6 plus 6, 0. Yes, I'll buy that one. Okay, how about 2? 2 squared is? Minus 5 times 2 is? Say again? Negative 10. 4 minus 10 is? Negative 6 plus 6 is 0. Yes, they both work. Okay, we found all the x's that made f of x equal 0. Does that make sense? All right, there's a checkpoint after it. Please do the checkpoint as soon as you can after class. So, any questions? Any? All right, let's clear it and do example 6. Find the values for x of x for which f of x equals g of x. Okay? Here's the first one. F of x is equal to x squared plus 1, and g of x is equal to 3x minus x squared. Right? Okay. Now what are we looking for now? Second? Set them equal to each other. Here's your f of x is x squared plus 1 is equal to g of x is 3x minus x squared. That's what it said to do. Do it. Figure out what f of x is. I gave it to you. And set that equal to g of x. I gave you that one. Now how do you solve that? I heard an add. Add x squared. Is that what I heard? Say yes. Okay. Add x squared to both sides. Right? Because that's going to wipe out that one. Now what are we aiming here? Let's go back and review this. When you have just an x in your equation, that's called a linear equation, you solve for x. Get all the x's over here, all the non-x's over there. That's what we did with 5a. Okay? But in 5b and 6a, when we have a quadratic, we get everything on one side, 0 on the other side. So you can factor and work from there. Okay? So let's get everything on one side. So if we're moving our x squared here, we also have to move the 3x. So what do we have to do with that? Subtract 3x from both sides. Now it's a little crowded on the left, so let's spread it out a little bit. What's x squared plus x squared? 2x squared minus 3x doesn't have a like term, and plus 1 doesn't have a like term. But plus 3x minus 3x is 0, and minus x squared plus x squared is 0, so that gives us 0. That's exactly what we want. Anytime you have squares, you want a 0 on this side. Yes?
I don't got my glass with me, so can you tell me, let's say if I'm the x squared plus 1.
Okay. Okay. What we did was subtract or add x squared to both sides, so that came here. And then we subtracted a 3x from both sides, because we had to get a 0 here. So that's a minus 3x. I didn't want to put it right under the 1 because they're not like terms. These I wanted together. X squared plus x squared is 2x squared. Then we have a minus 3x strung in there, and then a plus x. Plus 1, sorry. Is that what you're asking?
Yes, sir. Okay.
And that, over here we have plus 3x minus 3x is 0, minus x squared plus x squared is 0. Exactly what we want over there. Anything higher than an exponent of 1, you want to get everything on one side, 0 on the other. All you had was x to the first power, then just solve for x. Get all your x's over here, all the non-x's on the other side. Well, anything higher, get 0 on the other side. Okay, what do we do with this? Say again? Okay, there aren't any like terms. This is a square term, x term, and a constant term. Say again?
Do you take, okay, at the boss one, you take the 2 and times by 1.
Okay.
And you find the
Okay, what are you doing? Okay, now I don't want to offend anybody in this room. Anytime you have a quadratic equation that's maximum exponent of 2, what you want to do, if you can, is, and I'll also ask you this question. Now, if this is offensive, I won't do it anymore. I'll say, what's the F word? Factor. All right, in this class, it's factor. Okay? I don't want to hear the other ones, okay? So, are y'all okay with that? Okay, in this class, what's the F word? Factor, okay? Let's see if we can factor that. Can we? Now, I think what we had was he was telling me how to do it, but he couldn't tell me what he was doing, okay? So you start with the first one. We unfold it, remember? Okay, what's the only possible factorization of 2x squared? Say again? X squared and 2x squared. When you multiply them together, you got to get a 2. Okay? I'm sorry? X and 2x. Oh, you're right. What in the world am I doing? Somebody needs to teach this class. Okay. Okay, x and 2x. Sorry about that. X times 2x gives you 2x squared, right? Perfect. Where do we look next?
The last number, the plus
Yes, and what does that tell you? These two signs have to be
sign,
the same, and since the middle sign is negative, these have to be negative and negative. Good. Now, what's the only possible factorization of 1? Wait, my pen's not working. Whoops, that's not it either. Okay. All right. Okay, I've got to. Okay. So the only possible factorization of 1 is 1 times 1. Okay? Let's see if this works. They don't have to work. Let's see if it does. For x times 2x is 2x squared. Then the outers are minus x minus 2x minus x minus 2x is minus 3x, and then plus 1. Yeah, they work. So we did it right. You can do the other things, and you might wind up with something that's wrong. So always check and make sure you got it right. Okay? Now, where do we go from here? So each of them, you have a product of two entities being 0, so either anytime you have a product equals 0, one or the other has to be 0. So either x minus 1 equals 0, or 2x minus 1 equals 0. Now we got a linear function, so we just solve it. What do we do? What's the first one come? X equal 1. Add 1 to both sides, you get x equal 1. Over here, what do we do? Add 1 to both sides, and that gives you 2x. That adds a 0 is equal to 1. And then what? Divide by 2. And that gives you x equal 1/2. Okay, we just found two values of x. Both of them should make those two equations equal. Guess what? I'm a cynic. I want to make sure they're right. So let's plug in x equal 1 here. And what do we get? 1 squared is 1 plus 1 is 2. High-level math again. So this side is 2. Let's do it over here. Plug in a 1, and you get 3 minus 1 is 2. We got 2 here, we got 2 here. That one works. Okay? Let's do this other. Ooh, fractions. Don't we love them? Say yes. Okay. Now, we plug in x equal 1/2. What's 1/2 squared? 1/4. Plus 1 is? Okay, 1 is how many fourths? 1 is 4/4. 1/4 plus 4/4 is 5/4. So this side is 5/4. Okay? Let's go over here. 3 times 1/2 is 3/2, right? 3 times 1/2, 3/2 minus 1/2 squared is 1/2 squared is 1/2 squared. Multiply by itself. 1/2 times 1/2 is 1/4. So you have 3/2 minus 1/4. Okay, 3/2 is how many fourths? Okay, if you have 3/2 of a pizza, there's a half pizza, there's a half pizza, there's a half pizza. And I want us to get that into quarter pieces. I got cut this in half, you get 2. Cut this in half, you get 2. Cut that in half, you get 2. How many quarter pieces do we have? Y'all don't like pizzas, do you? How many quarter pieces is 3/2 of a pizza? Okay. Multiply the numerator by 2. Oh, okay, 6/4? Is that what you said? Yes. Please say yes. Okay, say I said yes. 6/4. You multiply the denominator by 2, you get 2 times 2 is 4. 3 times 2 is 6. 6/4. 6/4 minus 1/4 is 5/4. Same thing we got here. Very good. Those fractions are fun, aren't they? My younger brother, when his girls were getting into fractions in school, he called it fun with fractions. And they hated it for it. Okay, never mind. All right. So both of those do work. Okay? That's the A part. Still need to do the B part, I think. Yes. Okay? So let's erase. Well, I didn't need to erase that. I don't know how this looks at home. I bet you it's weird to see things just start disappearing. Okay. Maybe it's weird sitting there in class, but I don't know. Not as weird here because I'm doing the erasing. Okay. Whoops. All right, let's do the B part. The B part is f of x is equal to x squared minus 1. I could have saved myself a lot of work there. X squared minus 1. And the g of x is minus x squared plus x plus 2. Is that it? I think so. How do we do that? Set them equal to each other. F of x is x squared minus 1 equal g of x is minus x squared plus x plus 2. Okay? And where do we go from here? Say again? Okay, yeah, we want to move everything to one side or another. I don't like starting off with a minus, so I'm going to move the minus to the other side. So we'll add x squared to both sides. And we'll also, say again? Subtract x from both sides. And we'll also subtract 2 from both sides. Okay? What does that give it here? Combine like terms. 2x squared, no, minus x, right? And then negative 3. And over here you get nothing, nothing, and nothing, okay? So that adds a 0, right? Yay or nay? All right, good deal. Yay, all right. Now what do we do? Factor, okay, if possible. Now if we can't factor, what else could we do? Anyone know? Quadratic equation. Oh boy, that was fun, wasn't it? But let's see if we can factor first. Where do we begin? X times 2x. Perfect. Next. Whoa, we got a problem, don't we? Because the sign is negative, that means these two signs have to be different. But we don't know which is which. So this is the trial and error part. Which way you want to do it? For plus minus or minus plus? I don't care. Say again? Plus minus. So let's just see. If it doesn't work, we'll change it. Okay? Now, what's the only possible factorization for 3? 1 and 3. But we don't know where to put what, so we'll just do it this way. Now what do? Swallow it and see if it works. X times 2x is 2x squared. We know that one works. Okay? Now let's do the outer. Minus 3x, right? Inner is plus 2x. What does that give us? Minus x, and then minus 3. Y'all are just too good. We should have made a mistake there. Had an error, then we'd have to change something. No, you got it right the first time. You were looking at the book, weren't you? Okay, no. All right. Good deal. You got it right on first try. Now what do we do? Okay, so each of them equals 0. X plus 1 equals 0. Why? Because anytime you multiply two things together, give you 0, one or the other has to be 0. Or 2x minus 3 equals 0. What does the first one give you? X equals negative 1, or what do I do here? You say, yeah, oh, look at that. Do it in one step. X equals 3 halves. Now, if you don't know how to do that, just take it one step at a time. How do you eat a 5,000-pound elephant? One bite at a time. So if you don't understand just jumping to an answer, take it one step at a time. Add 3 to both sides. 2x equals 3. Divide by 2. X equals 3 halves. Not that much more to do, but there are 2 possibilities. Let's see if they work. Let's plug in the x equals minus 1 here. What's minus 1 squared? 1 minus 1 is 0. So this side is 0. Let's see what happens here. Minus 1 squared is positive 1, but you negate it, and it becomes a minus 1 plus 1. No, minus 1 minus 2. Sorry. Minus 1 minus 1 is minus 2 plus 2 is 0. That one works. Now the fun one, okay? Let's do 3 halves. What's 3 halves squared? Come on, quick. 9/4. Minus how many fourths is 1? How many fourths is 1? 4/4, right? So 9/4 minus 4/4 is 5/4. Okay, so this side is 5/4. Remember that. Okay, let's do it here. Say again? We love our fractions. No, they're your best friends. Fractions are friends, friendly fractions. Okay. So, minus 9/4, right? Plus 3 halves. How many fourths is 3 halves? 6 fourths. Minus 9/4 plus 6/4 is minus 9/4 plus 6/4. No, this isn't working, is it? 9/4 plus 6/4 is 3/4, isn't it?
Yeah, negative 3/4.
Oh, yeah. Yeah, you're right. Negative 3/4. I was doing the first one. Okay. Negative 3/4 plus, how many fourths is 2? 8/4. So, minus, y'all said 3/4 plus 8/4 is minus 3 plus 8. 5/4, and that was 5/4. Remember, should have written them down. It made it easier. Right? Hey, at home you can take all the time you want. Okay? Take your time. Do it one step at a time. I'm kind of rushing because we need to move on. All right. They got 3/2 and minus 1 for the A. No. Minus 1 and 3/2 for the B part, and we had already done the first one, which is 1 and 1/2. They have checkpoints there. Please do your checkpoints. Right? Now, let's move on. Any questions before we move on? Have questions, please ask. Got them? Okay. All right. What do we mean by the domain of a function? Tell me. What do we mean by the domain of a function? Oh, we talked about this last week. That was a long time ago.
The domain is I think it's the first number or second.
Yeah, the input, what you put into the function, domain of a function. Okay? Now, I've already been hinting at this, and hopefully you got it. The domain of a function can be described either explicitly, okay? I'll give you an example of that in just a second, or it can be implied by the expression used to define the function. Let's start with the explicit, okay? My younger brother used to work for an electric company. One of the jobs he had, he was like a vice president for something, operations, I think it was. What he did, it was a small rural electric company, what he did at the end of every year, he had to go back and look at the previous 5 years to see what their costs were, what their equipment cost, what their personnel cost, what the cost of electricity, because they had to buy some of their electricity from Georgia Power that's delivered in Georgia, or they had to make their own, and what the fuel costs, all that kind of stuff. He had to figure out all the costs. Then he also had to look for the past 5 years what the revenues were, how many customers they had, what rate they were doing, all that kind of stuff. Okay? Then he looked at the last 5 years and saw whether the customer base was increasing or decreasing. Okay? And he looked at all sorts of things over 5 years. Okay? Last 5 years. Then he had to put all that together and project what was going to happen the next year. You know, that's all he had to work on. He didn't want to go 10 years back. Things were so different back then. Okay? So his explicit domain was the previous 5 years. Okay? So that was it. He only looked at year, like if it was this year, 2020, he would look at 2016, 16, 17, 18, 19. No, 15, 16, 17, 18, and 19. That was his explicit domain. He wouldn't look at anything before that. He sure didn't look at anything after that. That was his explicit domain. Okay? Now, the implied domain is, okay, on that one, our initial assumption is always, let's assume all real numbers, unless we find some that won't work. That's the implied domain. Okay? There is another implied domain, and we'll get to that too. Okay? So what if this is your function? Alpha of x is equal to 1 over x squared minus 4. What could be a problem here? Where is your variable? In the denominator. What can denominators never be? 0. So your implied domain is, this is okay for any real number in the world, except you can never divide by 0. So in other words, here's how I do it. The book does it a little bit differently. Here's how I do it. This implies that x squared minus 4 cannot equal 0, right? Because the denominator cannot be 0. Now, what can we do to solve that inequality? You could do that, but you tend to make errors if you do that. What? Yes, you factor. How will x squared minus 4 factor? X times x plus and minus 2 and 2. Perfect. Y'all are good. Set those equal to 0. Oh, this can't equal 0. Right? Because it's cannot equal 0 up there. So what do we get here? X plus 2 cannot equal 0 Now this is not an or anymore. This is an and. And x minus 2 cannot equal 0. What does that first one give you? X cannot equal negative 2 and x cannot equal 2. That's it. All real numbers except x can't be negative 2 and it can't be positive 2. Okay? Those two values, and they write them like this, and that's okay too. That's your implied domain. All other values are fine. Okay? Now that's one way to write your answer. They say you can write out the words has an implied domain consisting of all real x's other than x plus or minus 2. That's a lot of writing. So I like to write it this way. X cannot equal plus or minus 2. That's so much shorter, okay? And that's what we got here. Is it time? Oh, how could it be? Let's finish this real quickly. So that's your implied domain. X cannot equal plus or minus 2. Next time when we come in, I'll tell you another way you can write this domain. Let me give you some homework exercises here before we leave. And that will be, remember you had 5 or 7 before. They're both at Calc Chat. 7's at Calc View. 9's at Calc Chat. 11 through 17 are at Calc Chat. 11's at Calc View. Any of the odds 19 through 29, they're all at Calc Chat. 29's at Calc View. Either 31 or 33, they're both at Calc Chat. Then any of the odds 35 to 41, they're all at Calc Chat. 37's at Calc View. 43 or 45, they're both at Calc Chat. 43's at Calc View. And we'll stop there and pick up the rest of those next time.
What chapter?
This is 1.4, section 1.4. Okay, you want to, okay. Page 44 and the first part of 45. You need a picture? Okay. I meant of me. No, I'm just kidding. No, I didn't mean that. I said, okay. It's this one and this side here.